In this segment we're going to talk about multiplying integers, and I'm going to show you three different ways of thinking about it or ways of teaching it for the students to be able to understand what it is that's going on when we multiply integers. Our first technique I'm going to call the group technique, and so here's our first question, positive 2 times positive 3, or we can think of it as I'm going to add 2 plus 2, add 2 groups, multiplication means of positive 3. So this question could be stated as I want to add 2 groups of positive 3. And there's my 2 groups of positive 3. There's one group there and another group there, and therefore we have an answer of positive 6. I'm going to leave my questions up here on the left hand side so we can see them later. And our new question is positive 2 times negative 3. And so using this groups of idea, I'm going to add 2 groups of negative 3. And so I need to have 2 groups of negative 3. And there they are. So my first group is across, I have 2 rows. One row of negative 3, another row of negative 3 for a total of negative 6. So positive 2 times negative 3 is negative 6. And my new question is negative 2 times positive 3. And so to state this one, we want to say I want to take away 2. Negative 2, subtract 2, take away 2. I want to take away 2 groups of positive 3. But I don't have anything at all. I can't take something away when I don't have anything. So what do I have to do when I'm stuck with the chips? Often it comes down to working with the 0 pair. So if I add 0 pairs, 2 groups of 3, so here's 1, 2, 3 groups. And so I want to find groups of positive 3. So there's 3 positives there, and I haven't changed anything. I still have a 0. So then I need 2 groups of those. So here's another group of positive 3s, but they're not really positive 3s, they're actually 0s. So I want to take away 2 groups of positive 3 from absolutely nothing. I still have absolutely nothing, mathematically speaking, and so now I have things that I can take away. So I want to take away 2 groups of positive 3. So now I can take away my 2 groups of positive 3. There's 1, 2, 3. There's one group of positive 3, and 1, 2, 3. There's my other group of positive 3. So if I want to take away 2 groups of positive 3, I'm going to end up getting a negative 6 answer. So negative 2 times positive 3 equals negative 6. And our last question is going to be negative 2 times negative 3. So to phrase this in the group technique, I want to take away 2 groups, subtract 2, negative 2. I want to take away 2 groups of negative 3. But again, I don't have anything here at all to take away. So therefore I need to put something in there that I can take away that's not going to change anything. So if I put in a bunch of 0 pairs, I still end up having a 0. So I need to take away 2 groups of 3. So here's a group of 3. And then here's another group of 3. And now I have something that I can take away. Right now I haven't changed anything. I still have one big pile of 0. So I can go back and I say I want to take away 2 groups of negative 3. I've got some negative 3s that I can take away. So now I'm going to take those away. And so I'm taking away the negative 3s. There's one group of negative 3. And there's another group of negative 3 that I've taken away. So taking away 2 groups of negative 3 gives me an answer of positive 6. So negative 2 times negative 3 equals a positive 6. This next technique I'm going to call the opposite of technique, and it requires students to understand that 2 groups of 3 is going to give me 6, and then 2 groups of negative 3 will give me negative 6. So we can use our chips to show that we're going to add 2 groups of 3 and that got 6, and we're going to add 2 groups of negative 3 and that got negative 6. Those ones are pretty straightforward. Not too many students have difficulty with that. It's these ones over here that students have difficulty with. So we're going to use the opposite idea. Because this question says I'm going to add 2 groups, I'm going to have positive groups of positive 3. We're going to talk about this question. So this one has positive groups, two positive groups of positive 3, and this one has two negative groups of positive 3. So there must be an opposite in here someplace. So I've got the opposite of positive 2, I now have a negative 2. Everything else is the same. So if two groups of 3 is positive 6, the opposite of that must be negative 2 groups of 3, which would be negative 6. And the same thing for this question over here. If adding two groups of negative 3 gives me negative 6, if I'm going to do the opposite of that, instead of adding two groups of negative 3, I'm going to take away two groups. Then if two groups of negative 3 is negative 6, the opposite of that would have to give me positive 6. So taking the two that we understand quite easily and using the idea that I'm doing the opposite of that, because my number of groups, instead of adding groups, I'm taking groups away. Instead of adding groups, I'm taking groups away. And so my answers are going to be the opposites of. So that's another way that students might want to relate to the multiplication of integers. The third technique I want to talk about is the array technique. And we've talked about multiplication using an array before, so that on the left-hand side over here, we have one of our factors, and across the top is our other factor, and in here would be our product. And so we can still use the integer chips for this multiplication array. And the idea that we have to talk about is if this is a positive, the opposite of that would be one of these. And if we're actually using the actual chips, we could just flip one from one to the other. So here's our first question, positive 2 times positive 3. And here's our setup. One of our factors is positive 2. The other factor is positive 3. A 2 by 3 array will produce an array of 6 in a rectangle. There they are. And so positive 2 times positive 3 gives me a positive 6. There's no opposites or changing or flips necessary, so this is a pretty straightforward starting point. And it goes along very nicely with what we've done with multiplication of whole numbers. And here's our next question, positive 2 times negative 3. So we have one of our factors is positive 2, the other factor is negative 3. And a 2 by 3 array is going to give us 6 circles. The question is, what colors will the 6 circles be? So we're going to start off with just saying 2 times 3 is 6, and we're going to assume everything stays as positive. So there's my starting point. However, we have one of my factors is negatives. Therefore, I have to do the opposite of 2 times 3. Now, we just got finished saying 2 times 3 is positive 6, so this can't also be positive 6 because it's not 2 times 3, it's 2 times negative 3. So since I flipped these ones into a different color, I have to flip my answer to a different color. I have to do the opposite of this. And that ties in with that idea of the opposite of. And so my answer is going to be negative 6. 2 times 3 gives me 6. It's important that students understand that 2 times 3 is always going to give us 6. It doesn't matter if it's positive or negative. It's going to be a 6. The question is, which kind of 6 is it going to be? And because we had to do one set of flips here for this factor, I have to do a flip for my answer. On this question, we have negative 2 times 3. Instead of positive 2 times negative 3, we have negative 2 times positive 3. So on this side, they've now switched to a red color because they're negative, and on this side we still have positive because the positive 3 is positive. And so 2 by 3 array is always going to give me 6 in the product, and so we're going to start off assuming that they're positive, and that gives us our 6. But 2 times 3 is 6. Positive 2 times positive 3 is positive 6, and we don't have positive 2. We have a negative. So we flipped one of our factors. Since we flipped one of our factors, we have to flip our answer as well. And therefore I'm going to get a negative 6 answer. So negative 2 times negative 3 is negative 6. 2 times 3 is 6. I've got one flip in my question, so I have to have one flip in my answer. And we finish with a difficult question, negative 2 times negative 3, and it's going to produce a positive 6, which is confusing. We're going to take a look at that. We have negative 2 times negative 3. 2 times 3 is going to give me an array of 6. We automatically assume that it's going to be a positive 6. That's our starting point. So there's our 6. However, one of our factors has changed its color, so therefore we need to do a flip for my answer just like we did in the past. And so we get an answer of negative 6. But the other factor has also flipped from a yellow to a red, and therefore our answer has to be flipped yet again. and so our answer is going to become positive 6. So 2 times 3 is 6. Negative 2 times negative 3, there's two flips, one in this factor and one in that factor. So my 6 had a flip to a negative, and then it flipped again back to a positive. And so since I had two negatives in my question, I had two flips, and two flips ends up bringing me back to my positive answer again. No matter what technique that you use to show the multiplication of integers with students, if you leave the questions up on the board while you're working on them, you'll find that students will be looking for patterns to see if there's a shortcut way of doing this. And they're going to notice these patterns. Now, if you're talking about the groups of, if I have two groups, I'm going to add two groups. If I add groups of positives, I get positive. If I add groups of negatives, I get negatives. If I subtract groups of positives, I still get a negative, and if I subtract groups of negatives, I get positives. When students take a look at it this way, they'll notice that if the signs are the same, the answers always come out to be positive. If the signs are different, it doesn't matter which order they're in, the answers are going to be negative. If you were using the opposite technique or the flip technique, in this one there were no opposites necessary, and in this one, or no flips, and in this one there were two opposites, and the two opposites canceled each other out, or the two flips ended up canceling each other out, getting back to a positive color. When they did these ones, there was only one opposite, so the answer became negative, or if we're doing the flips, there was only one flip, and therefore my answer had to be negative. Same thing on this question, there's only one opposite right there, or there's only one flip right there. So whenever there's only one opposite or one flip, my answer is negative. So either way, they're going to come up with a rule of when there's no flips or double flips, you're going to get the answer of being positive, and if there's one flip, you're going to end up getting the answer of negative. So students are going to come up with the idea eventually, after enough examples, that if the signs are the same, the answer is positive. If the signs are different, the answer is going to be negative. Here's your warning. Once this rule has been shown, they're going to want to use it for every single operation. So those students that were rocking the adding and subtracting using the chips and understanding it well are suddenly going to want to come back and use this multiplication rule for the adding and subtracting. And it'll all go terribly wrong very, very quickly. So you want to make sure that the students understand that this rule that you've come up with of the signs being the same, answer is positive, and the signs being different, the answer is negative, only works for multiplication. When we talk about division, they'll find out that it also works for division, and that makes sense because multiplication and division are related. So just be aware that once this rule is out there, it's going to cause havoc.